NASA scientists were able to obtain something that revealed what is inside a black hole. So join us as we bring you the most up-to-date information on what researchers have discovered within a black hole. In this video, we'll take a look at what's inside a black hole and why it is a terrifying discovery. The black hole at the center of the Perseus galaxy cluster has been linked to sound since 2003. This is because astronomers discovered that the black hole's pressure waves caused ripples in the hot gas in the cluster, which could be translated into a note that humans cannot hear 57 octaves below middle C. This black hole sound machine now has more notes thanks to a new sonification. This year's Black Hole Week will feature a new sonification, or the translation of astronomical data into sound. This sonification is unique in some ways because it revisits actual sound waves discovered in data from NASA's Chandra X-ray Observatory. The widespread belief that there is no sound in space stems from the fact that most of space is essentially a vacuum, with no medium for sound waves to propagate through. A galaxy cluster, on the other hand, contains massive amounts of gas that envelop hundreds or even thousands of galaxies within it, providing a medium for sound waves to travel through. The previously identified sound waves in Perseus were extracted and made audible for the first time in this new sonification. The sound waves were extracted in radial directions, that is, from the center outwards. The signals were then resynthesized into the human hearing range by scaling them up 57 and 58 octaves above their true pitch, respectively. Another way to put it is that they are heard 144 and 288 quadrillion times higher than their original frequency. The radar-like scan around the image lets you hear waves emitted from various directions. Blue and purple in the visual image of these data represent X-ray data captured by the Chandra. Aside from the Perseus galaxy cluster, a new sonification of another well-known black hole has been released. Scientists have been studying Messier 87 or M87 for decades, and the black hole gained a celebrity status in science after the first release from the Event Horizon Telescope project in 2019. This new sonification does not use EHD data, but instead examines data from other telescopes that observed M87 on much larger scales around the same time. The visual image consists of 3 panels, from top to bottom: X-rays from Chandra, optical light from NASA's Hubble Space Telescope, and radio waves from Chile's Atacama Large Millimeter Array. The black hole is found in the brightest region on the left of the image, and the structure to the upper right is a jet produced by the black hole. Material falling onto the black hole creates the jet. From left to right, the sonification scans across the 3-tiered image, with each wavelength mapped to a different range of audible tones. Radio waves are assigned to the lowest tones, optical data to the medium tones, and the Chandra detected X-rays to the highest tones. The brightest part of the image corresponds to the loudest part of the sonification, and this is where astronomers discovered the 6.5 billion solar mass black hole imaged by EHD. The Chandra X-ray Center led these sonifications, which were part of NASA's Universe of Learning program, with additional support from NASA's Hubble Space Telescope and Goddard Space Flight Center. Kimberly Arkand, a visualization scientist, astrophysicist Matt Russo, and musician Andrew Santaguida spearheaded the collaboration. The Chandra program is managed by NASA's Marshall Space Flight Center. The Chandra X-ray Center of the Smithsonian Astrophysical Observatory controls science from Cambridge, Massachusetts, and flight operations from Burlington, Massachusetts. So if you are content to go through life without knowing what a supermassive black hole sounded like, you've had your luck run out. The audio clip depicts actual sound waves emitted by the massive black hole at the center of the Perseus galaxy cluster, which is located more than 200 million light-years away. The sound is edited so that human ears can hear it. NASA combined it with other data and amplified it, claiming that the notion that there is no sound in space is incorrect. The misconception that there is no sound in space stems from the fact that most of space is a vacuum, with no way for sound waves to travel, NASA tweeted. A galaxy cluster contains so much gas that we've detected actual sound. It is amplified and mixed with other data to produce the sound of a black hole. The clip, which sounds like a cosmic growl or an ominous wind tunnel, piqued the internet's interest, and many said it sounded exactly like a supermassive black hole. Others used images of horror to describe it, and some remarked on how ethereal it was. You just knew a black hole would sound like terrifying ghosts instead of gentle ocean waves, one Twitter user wrote. Some used pop culture to describe it, citing sci-fi cult classic Event Horizon and horror film Silent Hill. One Twitter user compared it to Pink Floyd's Echoes, while another joked that it was new music from Icelandic singer Björk. And one internet user thought it sounded more like bodily functions than anything else. This sounds exactly like my stomach at 6:30 p.m. after the early evening shows have ended. #hungry in space, wrote another user. The agency described it as the result of pressure waves emitted by the black hole at the time, noting that it was 57 octaves below middle C, implying that scientists had to raise the frequency quadrillions of times to make it audible. Astronomers discovered that pressure waves emitted by the black hole caused ripples in the hot gas of the cluster, which could be translated into a note 57 octaves below middle C, they said in a statement. The singularity at the center of a black hole is the ultimate no man's land, a place where matter is compressed to an infinitely small point and all concepts of time and space collapse. It also does not exist. Something must replace the singularity, but we don't know what. It's possible that matter isn't squished down to an infinitely small point deep inside a black hole. Instead, the smallest possible configuration of matter, the smallest possible pocket of volume, could exist. A Planck star is a theoretical possibility envisioned by loop quantum gravity, which is itself a highly speculative proposal for creating a quantum version of gravity. The universe around us is composed of tiny discrete chunks, but at such an incredibly small scale that our movements appear smooth and continuous in the world of loop quantum gravity. This theoretical chunkiness of space-time has two advantages. One, it brings quantum mechanics' dream to its logical conclusion by explaining gravity in a natural way. Second, it prevents singularities from forming inside black holes. Because of this resistance to further compression, the material eventually uncollapses, rendering black holes only temporary objects. However, due to the extreme time dilation effects around black holes, it takes billions, if not trillions of years for them to go boom from our perspective in the outside universe. So we're all set for the time being. The Gravistar is another attempt to eliminate the singularity that does not rely on untested quantum gravity theories. My spell checker didn't even recognize the word because it's such a theoretical concept. The Gravistar differs from a black hole in that it is filled with dark energy rather than a singularity. Dark energy is a substance that pervades space-time and causes it to expand. It sounds like science fiction, but it's true. Dark energy is currently at work in the larger cosmos, accelerating the expansion of our universe. The concept of a single point of infinite density is derived from our understanding of stationary, non-rotating, uncharged, rather boring black holes. Real black holes have far more interesting personalities, especially when they spin. A rotating black hole's spin stretches the singularity into a ring. And according to Einstein's general theory of relativity, once you pass through the ring's singularity, you enter a wormhole and emerge through a white hole into an entirely new and exciting patch of the universe. One difficulty is that the interiors of rotating black holes are extremely unstable, and this is based on the same math that leads to the prediction of traveling to a new universe. The issue with rotating black holes is that they, rotate. The singularity, stretched into a ring, is rotating at such a breakneck speed that it generates tremendous centrifugal force. In general relativity, strong centrifugal forces act like anti-gravity. They push rather than pull. The formation of an inner horizon sows the seeds for the black hole's demise. However, rotating black holes do exist in our universe, indicating that our math is incorrect and something strange is going on. What exactly is going on inside a black hole? We don't know. And the frightening part is that we might never know. And with that being said, it's time to end our video. Subscribe to the channel for more amazing videos like this. We'll see you with another interesting video.